Welcome everybody. Today we have Unitary versus split heat pump water heating systems with Eric Vina from Smart Planet Supply. Before we get started, I just have some housekeeping slides to let you know a little bit more about 3CRN. Next slide. Before we get started, I know y'all are familiar with Zoom by now, but we ask that everybody is on mute for the duration of the training. And if you have any questions, please raise your hand or drop your questions in the chat. We'll get to them as soon as we can. I know Eric's really good at checking the chat as well, so we'll get to you. Next slide, please. A little bit about the Tri-County Regional Energy Network, 3CRN, for anybody who's not familiar with us. We're a collaboration between Santa Barbara, Ventura, and San Luis Obispo counties. We come together to create programs that reduce energy use and are more sustainable, equitable, and economically vibrant for the Central Coast. We are funded by ratepayer dollars through the public goods charge. And the good thing about doing that is that we get to bring dollars back into our region. And next slide. We currently have 6 programs. The one bucket being incentives, which is a home energy savings and commercial energy savings program. Another one being training, which we have building performance training program and the Energy Code Connect program. And last but not least, we have the technical assistance bucket, which is agriculture, energy solutions, and energy assurance services. I'll drop in the link to our website so you get a little bit more in-depth information about each program. If you have any questions, please let me know as well. And with that being said, I'll hand it over to Eric to get us started today. Thank you.
All right. Hello, everybody. Welcome. I exploded one of my tires today, so I'm at home and a little out of my element. So I apologize if my cats like jump on the computer or something, or start yelling at me to feed them. But otherwise, I think should be all right. So welcome to Unitary versus split heat pump water heaters. I'll be taking a break here and there to answer questions. So like Itzel said, please ask away. And with that, we'll get started. So I know that heat pumps in general and heat pump water heaters aren't really, like new at this point. They're becoming required in a lot of places, California-ish. But we still have a lot of this sort of institutional inertia and just kind of old habits that result in stuff like bad installs, misapplied technology, unhappy end users. And so, uh, happy to be here today. We're going to go over kind of some of the myths around heat pump water heaters in general, the differences between the two form factors, and kind of help you pick which one's going to be right for your job, how to size them right. And first, we're going to do a little bit of review because it's always good to know how stuff works. Why can't you just approach a heat pump water heater like a gas or an electric tank? Definitely can't do it like an instantaneous. Um, how do we describe their performance? And what difference do refrigerants make? Um, oh, there we go. So all heat pumps use a refrigerant, and a refrigerant is a working fluid that is going to change phase. It's going to change from a liquid to a gas at really low temperatures, usually way into the negatives Fahrenheit. Um, and that might not seem like a particularly useful thing, but pressure changes the point at which something changes phase. So you can manipulate pressure in a closed system and sort of force it to go liquid or force it to go gas. And transitioning to a gas absorbs energy, right? And going back to a liquid form releases that energy, which gives us the ability, those two things give us the ability to basically pull heat out of one system, move it, and then pretty easily release it into another system. And that's how heat pumps work, just in a nutshell. Specific refrigerants have their own operating parameters. They have, different pressures they'll condense or evaporate at. Um, they like different conditions, different ambience, stuff like that. Um, so they're all a little bit different. This doesn't From a service side, this doesn't impact heat pump water heaters that much, but it is good to know because ambient temperatures, especially, are kind of one of those big parameters that can cause a little bit of an issue with them, um, which we'll get into. Another side of that is that for a while now, we've been sort of working on this thing. You might have heard of the Kigali Amendment. That's to the sort of the Paris climate thing that happened a few years ago. And basically it's just a big international agreement that, hey, let's not, destroy things as fast as possible. Maybe we should really look at reducing the environmental impact of some of the stuff we're using. Um, and that is driving a phase out of a lot of things, including 134A in theory, if the government actually ends up doing it. But 134A is going to be the most common refrigerant in a unitary system. So it is eventually going to change some stuff. Um, like I say, 134A is really the most common one in heat pump water heaters. To a lesser extent, you see stuff like 410A. Both of those are being phased out, or theoretically being phased out. Um, Occasionally you'll see something mentioning R32, which is one that is probably going to be a little bit more common over the next couple of years. And then 1234YF is probably going to be the landing place for heat pump water heaters. It's pretty close to 134A, but it's got a vastly reduced GWP. That's the equivalent global warming potential relative to a ton of CO2. Um, and so you can see 134A has a GWP of what is it? It's like 1200 or something. Um, and then 1430. And then the 1234YF has a GWP of 5. So that's probably where we're going to be going. There are some R32 units in production too, and they're good units, but again, it's a little bit higher GWP. So I would figure 1234YF, and it's got a cool name too. It's nice and sequential. 290 is pretty exciting. That's propane, basically. It's a mix of propane and some other stuff. It works really well. It's widely adopted in Europe. That would be a fantastic thing to bring in and use as a refrigerant instead of burning it. But there's a concern about flammability, which I don't we've been pumping flammable gas into our kitchens forever. I don't really think it's that big of a deal, but right now that is the reason that it's not being allowed, is that there's a concern over the flammability of it. Um, Carbon dioxide is a really uncommon one. It's more on the commercial side, mostly because it requires just insanely high pressure, and it does have some limitations, but there is one, and it works really, really well. The operating temperatures have such a wide range that you can really use it in just about any climate. It's a cool one, and we're going to get into it because the one happens to be the split system that's on the market. So we'll talk a little bit more about that. Heat pumps use that pressure change to force the refrigerants to change their phase in specific places. For heating, we're going to pull heat from the outside air or your inside air, as we'll see, and we're going to store it, move it, and then release it into a different system. And then you just do that over and over again, and that's why you can see. It seems like it's kind of this cheat code where we can take heat from one place, move it to another, and have the effect of, kilowatts of electric energy heating a building or therms of gas heating a building at a fraction of the energy cost, because the only energy we're using is the energy that we need to compress or evaporate that refrigerant and kind of pump it from one place to another, and then the fan and the electronics that control it. So it's this tiny fraction. Um, of the energy it would actually take to if we were using something like an electric element or a burner. Um, yeah, and so it's one of those fun things. Physicists record the immutable laws of existence, and then engineers just find the most cost-effective way to lawyer those rules into unrecognizability for the sake of our comfort. It's ridiculous, and I like it a lot. Um, so last of the boring stuff, we do need to understand metrics when we're looking at the heat pump water heaters when we're trying to determine efficiency. The one you're going to see the most is COP. So that's coefficient of production, and that's the ratio I was just talking about of the energy we get out to the energy we put into a system. Um, and so electric resistance for reference is a COP of about 1. You put in a kilowatt of electric energy, you get about a kilowatt of heat out of it. Um, Gas is a little bit less than 1. Usually it's zero point 0.8 to kind of mid 0.9s because you always have a little bit of a combustion loss. Condensing boilers are making that a little bit better, but it's always less than 1. And then when we look at heat pump water heaters, usually we're going to be somewhere 2 to 3 at normal ambience. Ideally, we're around 3. That's kind of where we start saying, yeah, those are pretty efficient. Um, and it does range with a heat pump with available heat in your system. So if your heat pump's outside and it's really cold, there's a little bit less heat in the system. It'll still work. It just has to work a little bit harder. For stuff like heat pump water heaters, we can kind of get an advantage with this efficiency because if it's inside, your house is conditioned. It's always, 60 to 70 degrees in there. Heat pumps love that. They would be happy even a little bit less than that. So 3 is a pretty solid COP to look for in a heat pump. But they are rated by temperature. Usually there's like a little chart, or they'll tell you at, 20 degrees, they'll tell you during heating season and during cooling season. Um, you'll see less commonly the SCOP is really a European thing, but it is cool. It's seasonally averaged. So instead of saying, this is what your COP is at 80 degrees, this is what it is at 40 degrees. It's averaged over a season, so you can kind of say during your heating season, this is how it's going to perform. We've measured it, we've averaged it out. It's a nice reference. Especially on the consumer end because it is a real thing. It's not just lab conditions. It's you know this is roughly what you can expect if your climate is like this. Um, and then HSPF is the American version of SCOP, and that one you'll see published in a lot of literature. That uses BTUs, and of course, this is America. The numbers are bigger, but only because we're using BTUs instead of kilowatts. It's the same thing, seasonally averaged. UEF is like the seer of heat pump water heaters. I don't love it. It's not super useful except for comparing systems, but it is what a lot of the like rebate programs and government programs use. Um, and so because it's a qualifier, just about everything's going to have that listed as well. Um, so with that, we'll get into unitary versus split. So here's just some pictures of kind of explaining the difference. And you can see on the left here we have what look to be normal-ish, kind of fancy tank water heaters. And then on the right, again, we have a tank, and then we seem like we have a mini split and some cartoon characters for some reason. So when we talk about split and unitary, we're really talking about where the compressor is, right? Where the heat pump is relative to the tank. And a unitary system has the heat pump built into the tank. Generally, unitary systems are a little more comfortable to look at for people who are storage. It's just a little bit more intuitive. My water heater has always been that thing that's over there, and it does the thing. Unitary systems are laid out in a similar way, with just the notable addition of that weird fan thing on top. That's why we call them unitary. They create a unitary package. Um, Split systems then are exactly what you'd expect them to be. What you wouldn't expect is that they have an anime mascot, which is pretty cool. Tankman Square because Japan's cooler than us, but otherwise this is kind of that shows you the two parts of a split system. Your heat pump is separate from the tank. It looks like a mini split condenser. Usually they put them outside. And As just a note before we move too far on, I try to be brand neutral when I do these. I sell this stuff, but I try to be neutral with everything. In this case, I can't do that. As far as I am aware, there is only one split heat pump water heater on the market in the US, and it is the Senko 2. So there's other systems that build off the Senko 2, and you'll see them get listed. But generally speaking, everything is based on at least a Senko 2 heat pump. And if you see split heat pump water heater, it's probably a Senko 2. Um, so, right out of the gate, I would like to talk about some of the herd of elements or elephants in the room here. Unitary systems got the brunt of this, and I am guilty of saying these things myself. But there's some statements that you hear every single time you mention heat pump water heaters. Anywhere some guy with an opinion can hear you, they're loud, they make your house cold, they're slow, they make my heating bill go up. You can't fix them, and they're rooted in truth, right? But it's not different from any other technology. When we had a 2001 Corolla when I was growing up, a little subcompact car, and it got less than like 20 miles to the gallon. And you'd have a stroke if somebody sold you a compact commuter car that got 20 miles to the gallon today, right? It's just technology improves over time, things change. Um, and while they are kind of things to consider, they're mitigated much better these days as the technology progresses, as manufacturing scales up, and as processes get better. Manufacturers are iteratively improving every model they produce, and the limitations that we had with original systems are really shrinking every time they release a new model, and in many cases are kind of non-issues these days. You do still need to think about them, but it's not to the point where it's really egregious anymore. You do need to look at the documentation for the model you pick. There's just such a wide range of unitary systems out there that there's one for everybody, but you need to read your documentation and sort of make sure you're selecting the right one. Primarily, what you're looking at is volume of air and the noise levels. And we'll get back to sizing, but that's also really, really important when it comes to heat pumps. Um, but mostly when we hear horror stories about heat pump water heater systems, those are design and installation problems. It's the same thing, or you end user issues, right? Service stuff, maintenance stuff. But it's the same thing as a mini split back in the day, right? You can't slap a heat pump in where a gas system was and figure, yeah, it's the same thing. You really need to approach your design and your install thoughtfully, and just be mindful of how heat pumps operate. And if your install is good and you sized it right and you have enough air, the end user is going to end up having a good experience. Um, so, noise is one of them. The cold air they make is another one. That's a little bit. We'll get into that, but you, well, here, let's just move on, and I'll talk a little bit about unitary systems. So unitary systems, despite what maybe you've heard, like I said, they really get kind of a bad rap. They have so many advantages. They're readily available. They have a lot of big name brands producing a wide variety of systems. And that's really the key when you're looking at your project and you're trying to select a system, is there's a lot of units out there. And some of them are low end and some of them are high end, and things like your noise levels and your recharge rate and your output temps all vary between them. And even at the higher end, kind of one of the advantage to the unitary system is that they're not too bad, right? They're definitely, in terms of cost, they're definitely more than electric or gas. And it's when you're looking at price, it can be kind of a hard sell unless you are kind of looking at your big picture. Um, but they do have a lot of rebate programs to help right now, uh, unlike the gas and electric units. And because they have that COP greater than one, they are effectively paying you back over time. And with the unitaries, it really does not that bad. It does depend on your energy cost. It's a hard thing to tell you just sort of blanket statement. It will take X years for you for this to pay you back, right? But to go back to the car analogy, right? I used to drive a Honda Pilot and it got bad gas mileage. It was like 15 miles to the gallon on a good day. And I did the math on what I spent to feed it for a month and realized I could literally negate my payment by getting an EV. So now I drive an EV and I've had to make a couple of adjustments in my driving behavior and how I think about my car. But it's sort of the same thing with the unitary system is you might have to make a little bit of an adjustment, but effectively it's going to cost you way less to own and save you some money in the long run. Um, Install, that's cost of equipment. Install can make it a little bit different. I don't want to be unrealistic. Install can get expensive. It's gotten surprisingly expensive over the last few years, but it does need to factor into your budget. Um, The biggest advantage that unitary systems have over split systems is that availability and just kind of the diversity of the lineup. Like I say, there's a unitary for everybody. They can be big, they can be small, they can be sort of on the slower end and hyper prioritize your energy savings. They can be fast and really comfortable replacements for systems people are used to, and so they can be kind of a stair step on their way to maybe a something that is more prioritizing your energy efficiency. They're usually really programmable. They often have phone applications or built-in controllers that aren't a nightmare to use. We run into that issue a lot where controls can be sort of onerous, and so homeowners don't really want to use them. You can see like on this LG, it's got this really nice display here. It's very easy to use. And sometimes some of them, like the LG, are even kind of cool looking, right? Like it's this weird monolith square thing. That's not as big of a factor when people are looking at water heaters, but it is kind of neat. Generally speaking, all unitary systems are going to be on board with, or at least have the option to be CTA 2045. So that's that demand response measure that allows utility providers to trigger or block out your operation depending on their projected power availability. Um, and then the last one is a little divisive. Some people really like it, some people really don't, but most unitary systems have electric backup elements built into the tank. Um, and I really like that. I'm in favor of that. I'll tell you why. I am who everyone calls to complain. And most of the complaints I get from homeowners at least are about having to adjust behavior, right? Having to adjust their expectations for a piece of technology that behaves differently than they're used to. We'll get into the client education part as well. That's super important, but electric elements are kind of like I said, they're kind of like training wheels or like a parachute, right? Depending on how you look at it. If you're going for passive or something really, really strict energy performance standards, uh, they can be a little challenging to navigate around. But for everybody else, those electric elements are kind of a nice thing to have as we scale up our heat pumps and make the technology a little bit better. Um, so we still get our primary operation from the heat pump, but when it can't keep up with our demand, those backup elements are in there acting just like they do in an electric water heater. They're a little bit smaller, but they help us bridge that gap. And yeah, it increases your power use a little bit, but not to the extent that it's not still at least twice or three times as efficient overall. And most importantly, right, it's their house. If they want hot water, the heat pump alone isn't keeping up for them. The elements can actually be programmed. Usually, the unitary systems will have like a turbo mode or a plus mode or something that prioritizes the availability a little bit more and deprioritizes the power savings a little bit more. And so they'll kick those elements on and work a little bit faster. That can be a good option for folks who are maybe a little bit nervous about jumping from standard electric to something like a heat pump. To expand a little bit on those backup elements, the way that unitary systems are ready to go just out of the box, they tend to be configured in a way that prioritizes efficiency and comfort, and they kind of meet in the middle on them. We can program them to prioritize one over the other pretty easily. So they've got like that turbo mode, but they also will have an eco mode where it really, really wants to use the heat pump and not use the electric elements, which is another good thing to educate your clients on because sometimes they put them in that mode accidentally. But automatically the unit's gonna use the heat pump wherever it can, and if that's all it needs, right? Maybe everybody's asleep, there's no draw. It's just gonna chug away with the heat pump, and if that meets the demand, then that's all it's gonna use. If we end up with like a high flow fixture, there's a big shower, or there's just a period of high demand where multiple people are taking showers or taking showers one after the other, the unit will realize that the heat pump isn't kicking up or keeping up, and it will kick on the electric elements in the tank. And actually, I should say element because usually they'll only use one of those elements at a time, even though there's two in the tank. All water heaters do that. That's why when you look at their power ratings, the power rating matches the rating of one element instead of both of them. But I just wanted you to know that out of the box now, these systems are set up to sort of mimic maybe a little bit more familiar operation, um, something that's a little bit more comfortable for most folks. You don't have to work too hard to get them to be less noticeable, as long as they're sized right. So the real challenges that unitary systems have, like I said, the myths are sort of rooted in reality, right? They do need airflow, they do need space, they do make a little bit of cold air. Um, and so unitary, the big one is the space requirements with the unitary systems. Um, Feeding that heat pump requires a specific volume of air. This varies from model to model, but generally you're going to be around 700 cubic feet. Um, some are down, some are less than that, 600, some are more than that at like 800. Um, Generally that's going to be 10 by 10 by 7 room, or 10 by 10 by 8, or well, actually not 10 by 10, but as your ceiling gets higher, it's volumetric, so a higher ceiling actually kind of helps you have a smaller footprint that way. One way or another, though, you do need to get that airflow. um, if we have space limitations, there are a couple of things we can do. So louvered doors are one. You can see at this bottom picture here, they've got a couple of grills in this door, and this also looks to be an exterior application. Um, but then we have the water heater in this little closet. I don't know if I would put it in a space that small because you do still need to service it, you need to access stuff, and I would bet that fan is probably blowing on a wall, which isn't great. Um, but that is one thing you can do, and especially if you're putting it in like a laundry closet, something with a sliding door, you can put those louvers on there and effectively get a little bit more air volume without having it be visible in maybe an occupied area. The other thing you can do is run ducting to the outside, as we can see in the top picture here. So you can duct your intake to the outside. That's not one that I tend to recommend. It just makes you a little bit more vulnerable to ambient conditions. Yes, it stops you from feeding it conditioned air, but the conditioned air you feed it, it's a pretty minor load. And if you have an efficient conditioning system for your house, like a heat pump based system, you're not even going to notice. I tend to recommend just feeding it the air you have in your house, or whatever space it's in, as long as that's going to be within its ambient temperature requirements. Ducting your exhaust outside is a good way. If you have really, really strict space requirements, that can be a good way to make sure that you're not making that area too cold. You're not creating condensing surfaces in there. That's a real concern. That's why I was worried about this one being pointed directly at a wall. It is blowing out cold air, and if you have it 2 inches from your drywall, it will eventually just make that surface cold enough that stuff can start condensing on it, and it can end up in mold, and it's better to avoid for many reasons. So if you have a situation where you can only stick it in a closet, if you have the ability to run a duct out, you would still want to louver the doors in that case because you need to feed it. But running that duct out will mitigate a lot of those concerns about condensation, things like that, and it will help out, and it makes them a little bit more flexible. Um, and then if you are going to run those ducts, you do take a slight efficiency hit. It's not really enough to worry about, but it is there. The main thing is you need to insulate that exhaust duct, right? Or it will sweat. Kind of the Cliff's Note version on the Unitary, right? So this would be where you want to look up for your coffee. This is like the important thing. With Unitary systems, it is extremely important for your performance, your end user satisfaction, and the health of your system to size your tank correctly. You want to provide sufficient air volumes. You need to install with access to filters. This is one, I don't think I touched on this earlier, actually. So let's talk about that. Unitary systems have filters. You do have an air filter. It's kind of like the one in a mini split where you pull out that little wire mesh thing and you wash it off.